I can't believe you came to this talk. Did nobody read the description? Why are you here? Okay, hello. My name is Mark Smith, as has been previously mentioned, although I am generally known as GD2K online for reasons that aren't as funny as you might imagine. I am a developer advocate at a database company you may have heard of called MongoDB. We are a sponsor of the conference. Please come and talk to me outside if you're interested in storing data in any form. I would love to talk to you about MongoDB. In the meantime, I have been asked to make something very clear. My employer does not use or endorse any of the techniques in this presentation. And in fact, I do not use or endorse any of the techniques demonstrated in this presentation. Any harm you cause to yourself or your career by using these techniques are entirely at your own discretion. So on every computer that I've had for the last 20 years, because I'm quite old, I've created a folder called Stupid Python Tricks. I use it to build short scripts generally to try out features of Python in ways that won't pass a code review because they're too silly or weird. And I've lost some of that code over the years. These days I keep it in a GitHub repository, which I'll give you a link to later for your own amusement. And every so often, I like to take some of the code out and dust it off and show it to people to see how they respond. And if you feel the need to respond, please feel free to tweet at me at GD2K. This talk is in two halves, and in a moment I'm going to introduce you to a library called Ish. I'm going to show you two stupid tricks using a handful of techniques each. And in each half I'll try to describe what I'm trying to achieve, and then give you an idea of the route that I took to actually implement the thing, like the thought process that I went through to build it. So Ish, I wrote originally for a lightning talk at EuroPython about 7 years ago. It was a joke that got a little bit out of hand. It's now got its own repository on GitHub. It's had several contributors, which is worrying, as you'll see. So let's talk about types in Python. I like types, and Python is very forgiving with types generally as a dynamically typed language. But just to start talking about these things, here's how you compare two Boolean values. Now this is the same Boolean value, and we're comparing them for equality. And true is, as you'd expect, kind of equal. It's equal to itself. And false is not equal to true. So when you compare it with the equality operator, you get false. Now, you probably all know this. For historical reasons, 1 is also equal to true in Python, as I said, very forgiving with types, and 0 is considered equal to false. So if you compare it to true, it doesn't agree, it's false. But this is where it starts to get interesting. Now, if I compare a string containing the word true with the Boolean value true, that works, which is brilliant, right? Like, you get this sort of string input all the time, and I can compare it to a Boolean, and it tells me that it's true. The only problem is, this is also true, so if you put false in a string, because only empty strings are false, and the word false in a string stops it from being empty, which means that string is now true. I wonder how many times I say true and false in this talk. It's quite a few times. Well, this is not ideal. Like, this doesn't feel Pythonic to me. Like, we want something a bit better than this. So we want something that's not necessarily true, but true-ish. So this is what I'm going to show you how to build in the first half of this talk. I want to be able to suffix ish to the end of a sentence. For any non-native English speakers, this is something we do in English. It's kind of an idiom where we add ish to a word, and it means it's not quite as strong an opinion, right? It's like a fuzzy value. So I want to be able to compare different values and get something sensible like this. So I can compare false to true-ish, and it'll say, no, that's false. Now, you may be sitting there asking yourself this question, why? Why would I want to build this thing? And if you're asking that question, you may well be in the wrong talk. So I apologize for that. Next door, Donald Byrne is giving a talk on the next step in high-performance machine learning. It sounds fascinating. You'll probably learn a lot, and you've only missed the first few minutes if you're quick. But if you are staying here, let's get back to what I want. And I'm going to take a step back from this, which is what I ultimately want to write, to this. I'm going to take out that hyphen in the middle, and we're just going to try and create a value that we can compare against these strings and get back something that is more meaningful than this idea of strings that have characters in them or not. So how do I change how the equals operator works? Let me show you what happens when you compare two values using the equality operator. So behind the scenes, first, Python will take the left-hand operand, which is, in this case is a string with the value of the word true in it, and it will call this magic method called dunder, or EQ with these double underscores on either side. We often call these dunder methods, or special methods. There's a bunch of different terminology, and none of them are very easy to say, so I'm probably just going to keep calling this the EQ method. And it calls it on the left-hand value, and it passes it the right-hand value as its single parameter. Now, string is part of core Python, and the core Python developers never expected to encounter one of these true-ish values. I mean, we haven't really encountered it yet because I haven't implemented it yet. And so when an EQ is called on and the object doesn't know how to compare itself to something else, it returns this not implemented object. And so when it returns that to Python, Python has another go. And this time it calls the same method, but it calls it on the right-hand operand, and it passes it the left-hand operand as its parameter. So it's just the other way round. So it's having a second chance. And if true-ish knows how to compare itself to a string, then we can return something sensible like true. And if you're relatively new to Python, you may be wondering, how do I know this? So let me introduce a document called the Python data model. This is an absolutely fantastic part of the core Python documentation. It's relatively long, but it's really readable, and it explains how objects and attribute lookups and magic methods and metaclasses work in Python. And quite a lot of my stupid tricks that I've written over the years use things from this document to change the way that Python behaves. So here's the class I came up with. I called it trueish class, and then I implemented the dunder EQ method, and then I look for that other value inside a set. So I've created a list of things that I consider to be trueish, and if it's in there, then I just return true. And then if otherwise, then I look for it. I've got a set of falsy values, like 0 and no and off. And if it matches any of those, then I return false. If it doesn't match either of those, and we've kind of handed it something that it doesn't know how to compare itself with, then I raise a maybe, because I thought that would be funny. Let's try it out. So here I've instantiated my trueish class. Most of these magic methods and things only work on an instance rather than a class definition. So I've created an instance, and then I check it against my true value, and I get true, which I hoped for. And then I compare it against the string true, which I also hoped for. And both of these are true with just the true boolean. Is very boring. And so is comparing false to a trueish. That's just returning false. But this is what we actually wanted to achieve. So I'm comparing it to the string false. It finds it in my set of false values and then returns a false boolean. That's the first part of this done. But if you remember, there's a last test, which is where I compare it to some nonsense, like a string that contains the word lemons, and it raises my maybe, which is funny. So I was vindicated there. Here's the syntax I actually set out at the beginning with this hyphen here. But if we look at it closely, that's not a hyphen, it's a minus symbol. So we're actually doing a subtraction here. So we've already changed the way that equals works in Python with this object. So let's change the way that subtraction works. We have a similar approach to this. When I attempt to subtract an ish from true, first it will call this special method called sub. Dunder sub, if you prefer. And true has never seen an ish before. Neither have we, because we haven't implemented it yet. But so it returns not implemented. True will not. I can't persuade the core Python developers to re-implement their own subtraction with true to support my ish. And if it if it returns not implemented, again, Python has another go. But this time, equality works the same way no matter which way around the operators are, operands are, but subtraction doesn't. If you reverse the operands, it's got to do something different. So in this case, it calls a slightly different method. This is called rsub, which basically means doing subtraction, but we're calling the right-hand operand. And so I need to implement that, where when it's passed a sort of an ish on the right-hand side, if it's called on ish, and it will be passed either a true or false, then I return my true-ish that we just defined, or a false-ish, which I haven't defined, but it's basically the same as true-ish. It just returns the opposite values. I will leave implementing that to your own home study. So it's just an if statement. This is relatively straightforward. And now we can go and subtract an ish from true, and we get my true-ish class that we were looking at before. So if you were paying attention, you know that true-ish can be compared to the string true, and it returns true, or it can be compared to the string false, and it returns false. So this is our nice kind of fuzzy-ish value. I have put this in a GitHub repo called ish under my own, my GD2K account. If you enjoyed this, I recommend you check it out. The library that's uploaded to GitHub does a few extra things on top of what we've just implemented just now. For example, it supports slang and words from different languages. It can actually do fuzzy numeric comparisons, which is almost useful. It could... And I've recently removed this code to simplify some things, but a friend of mine, Jeffrey French, added a neural network to the library that allowed you to compare images, photos of people, to emotions like happy and sad, and it would return true or false if the photo was of somebody who was happy or sad, depending on the ish value that you pass it. So the thing that main thing I've been getting at in this part of the talk is that you can change the way that Python works by implementing these special values, special methods. You can change them in subtle ways, potentially, that may be surprising. They're a way of opening up a hatch into the Python language and just kind of rummaging around, and I think that's fun. So what have we covered in the first half of this talk? Well, I've shown you how you can change the way that equality works with your objects by implementing done.eq. I have also shown you how you can overload subtraction, so you can use the minus as a hyphen. Sadly, black doesn't yet format subtractions without the spaces. It will separate these things out, but I have a fork of black called blackish where I plan to implement this format. So, finally, you know about the Python data model, which describes much of the magic that you can do with Python. I highly recommend you check it out. So now we get to the second part of this talk, which I have called Fun with Math. Well, that's a lot of enthusiasm. Excellent. If you want a reasonably accurate version of Pi, you probably know that you can import the math module and access this module variable called Pi. And this is what it looks like. Now, unfortunately, the mathematicians in the room will tell you that that is not an exact value for Pi, because everybody knows that the correct value of Pi is 3. It's a nice, simple, round number. Now, fortunately, you can actually fix the math module's behavior. So I can import math. I can just assign the value 3, the correct value of pi, to math.py. And then, later on in my code, anywhere that imports math and then accesses math.py will get my new value that I just stuffed into the math module, because it's global throughout my application. The only problem is that I found in code bases where I've done this that my team members, my fellow developers tend to get a little bit upset with me. So it's best to sneak in the correct value of pi over time. You just have to be a little bit more subtle. So what I want to do is to be able to import math, and then every time I access pi, the value is just changing ever so slightly. It's just gradually getting closer to the correct value. So the idea is that the value is different every time you access math.py, and it just gets closer and closer to 3 over time, and hopefully nobody really notices these numbers at the end of this long list of digits is changing. And again, you might be asking yourself, Mark, why would you want to do this? And I would say, well, we're over halfway through this talk now. You might as well just sit to the end. So here, this is the implementation. The code could look a little bit like this. You can import math, and I've renamed it here. There's an underscore at the start of that, so I've renamed it to underscore math. And so I'm just storing away the original value of pi. That's just, I don't know what they did with that. They just added a whole bunch of extra digits to it. Now, every time I call this pi function, and in this case, I've simplified the logic. This isn't getting closer to 3. This is just adding a very small value each time because I wanted to keep the code short. But every time you call this function, it will return you a slightly modified version of pi each time. So what does it look like to use this function? Well, I can import my math. You see it's got a slightly different name. Excuse me, those weren't supposed to be up there. And every time I call that function, I get my slightly different value of pi. So we're quite close, but these are not right. You know, pi is not a function, it's a variable. So what I really want is, I need pi to be a function because it is executable code, but I don't want it to look like a function call. I want it to look like an attribute access, and every time I access pi, it calls the function behind the scenes. And Python has a construct for that. It's the property decorator. So the only problem with the property decorator is that it doesn't work on top-level functions. It only works on methods. So we kind of need to stick this in a class and make pi a method. Which isn't ideal, but let's just kind of go with this limitation at the moment, and I create a new math class and stick everything in there. And it has a nice side effect that I don't have to use the global keyword anymore, because it's no longer a global variable, it's just an instance variable that I'm modifying each time. So again, let's see what it looks like to actually use this code. So first I instantiate the class to get my math object, and then each time you see I access that pi attribute, I'm now getting a slightly different value of pi, which is great. But this is wrong, right? So now we're not importing that object, we're kind of instantiating it. And it's probably stored in another module, so we've got an import and an instantiation, which is just, you know, it's too obvious what's going on there. So what I need to be able to get this instance by importing math. So let me introduce you to the sysmodules dictionary. So this is part of core Python. Every time you import a module, Python will put that module into this dictionary called modules. The key will be the name of the module that's been imported, so in this case it will be the string math, and then the actual, the value will be the executable code. It's like the object that the module, that contains all the module code. So to demonstrate what I mean, here first I've accessed the math value from sysmodules, and it's not there because I haven't imported math yet in this program. So now I can import math using normal import keyword, and then after that, when I look up math, I get back this module object that contains lots of stuff. So I can compare that thing against the math variable that I just imported with the import statement, and they're the same thing. So that just shows that they're the same. There's no difference to them. And this is why I like writing stupid code in Python. Almost everything in Python is mutable. And because it's mutable, you can change it. So let's change it. Let's manually modify sysmodules and pretend that I've imported math at some point. So here I've instantiated my new math object, and then I've put it into sysmodules with the name math. And so later on in my program, where I actually import math, I get back the instance, the object that I put in there. So I'm not getting a module anymore, and Python will never load the math module after this because it thinks it already has loaded the math module. There it is. So you can put anything in sysmodules that you like because Python is a dynamically typed language, and this is wonderful. So here is, you don't even have to do this in the client code, right? You don't have to sort of import that object and instantiate it and then put it in modules. You can do it inside the module definition. So here where I've written the module that sort of provides this better pi object, I just sort of put it in when it's imported. So now this happens when you import my math helper module. So now when I import math helper, then afterwards I import math and I don't get math, I get my new math object, and then every time I access pi, I get a different value, which is great. So we're done, right? we're not done. So there's a little bit more, so I have a problem. It turns out math doesn't only contain pi, it also contains a function called ceal. And if it's missing from the math module, my colleagues may notice that I've corrected the version of pi and go looking for what I've done. So it's important to implement ceal. And it's relatively easy, right? It's just a proxy. I just pass that through to the original math module, return the result, and nobody will be the wiser. But so I'm done now, right? I'm not quite done now. So I had a look at the documentation for the math module, and it's really, really big. I did not know that mathematicians had learned so much stuff. Did you know that mathematicians had learned so much stuff? It was a surprise to me. So at this point, I realized I was going to have to implement a stub for every single thing in the math module. So this stupid trick started to get a little bit boring, which really isn't the point of writing a stupid trick like this. I started thinking about maybe I could loop through the math module and then automatically write a proxy function for each thing in there. And then I decided to take a step back and think about what's going on here. So let's have a look at this call of math.ceal. There's actually two things going on here. So the first thing that's going on is we're actually looking up an attribute on this math module, or this math object in this case. And then the second thing we're doing is actually executing that thing that was returned, because that thing that was returned, that was looked up, is a method. So what I need to do is I need to change that lookup, the first part of this, so that it just hands off to the math module and returns what's been defined. So let me tell you about the getata magic method, so the special method. It's a special method that you could implement on a class, and it will be called when you look up something on those objects that hasn't been defined. So in this case, if I hadn't implemented ceal on my new math class, it would call getata, and it would pass it the name of the thing that it's looking up. So this is a silly example, but I've got an object there that doesn't implement lemons as an attribute. And so when you try to access it, behind the scenes, it's calling getata and passing it the name of the thing that you're looking up. So I need to implement this method on my new math class and tell it that it should look up each item on the real math class, math module. So that way, if I try to access pi, I get my special value because it is implemented. If I try to access anything else, I get the original implementations. I haven't found any other bugs in the original math module yet. So let's go back to my new math class and replace my ceal implementation with this dunder getata. And inside, this is a really difficult thing to say out loud, it is calling the getata function. So bear in mind, that's not a dunder method. It's another utility within Python that allows you to look up something by name on anything, basically, anything that has attributes. So I'm just passing on that name through to the original math module and then returning whatever is returned to us. So there's some other stuff I should do to this class to make it look a little bit more like the original math module. I should probably use the docs attributes from the original math module. I should probably change the repr implementation so that when you print out the math module, it says that it's a module, even though it's not. Feel free to take this code as a starting point and see how far you get. Now, it's worth noting, just to be up to date, excuse me, that some of this isn't necessary anymore. When I first wrote this module, getata didn't work on modules. It only worked on classes, so I kind of had to swap that class in. Since Python 3.7, getata has been supported in modules. And so it works exactly the same way as it does in classes, but now it means you can implement dynamic attribute lookup as a fallback on a module directly. That may or may not be useful to you. So in this second half of the talk, what have we covered? Firstly, modules and objects are basically interchangeable. You have to manually modify the sysmodules dict, but that's more or less it. Modules can't use the property decorator, but objects can. And if you put an object where people expect to find a module, you can get behavior that's unexpected. Almost anything in Python is mutable, except some of the things that under the hood are implemented in C. And those can be a little bit more difficult to change. But then that's just another challenge for the aspiring stupid Python programmer. And finally, you discovered how to magically create any attribute you like when it's requested. It would be quite fun, for example, to implement something that allowed you to misspell method names and would still return you something that would work. In fact, I think I've come across a module on GitHub that does exactly that, so it's worth kind of Googling for. This code, or something like it, is available in my Stupid Python Tricks repo on GitHub. There's a bunch of stuff in there, including some more advanced tricks using things like metaclasses and directly implementing the descriptor protocol. But most of it takes advantage of the kind of things that I've shown you here today, modifying things you're not supposed to modify, and implementing dunder methods in ways that they weren't designed for. You don't have to be a Python expert to write weird and wonderful code. You just have to have some time and the urge to be creative. So if you haven't written any stupid Python code before, then this is just the start of your journey. There are plenty of special dunder methods and variables that change the way that objects behave when you access them or call them. If you don't know what the descriptor protocol is, I really recommend you Google it and have a play around. It explains the rules for looking up attributes on objects. Behind the scenes is actually how methods work. So it's where that self attribute goes when you call a method, which that was an absolute revelation when I discovered it. But it also explains how things like the property, class method, and static method decorators work behind the scenes. Eval is lots of fun. You can build Python code as a string dynamically and then execute it. It returns executable code that you can then pass around and do whatever you like with. And I really honestly would have liked to have covered metaclasses in this talk, but there really isn't time in a 35-minute slot. I don't usually recommend my own talks, but I gave a talk at PyCon Australia that was 70 minutes long, Introduction to Classes and Metaclasses, and I think it's quite good. So if you are interested in metaclasses, do check out that YouTube video. And then there's the dis package, which you can pass a function, and it will disassemble the bytecode in that function, and then you can modify it, and then recompile it back into executable code again. A friend of mine, Sebastian, wrote a package that allows you to implement goto in functions, and it's done entirely as a function decorator that disassembles the bytecode and then fiddles around with it to make goto work. And finally, the way that Python loads and finds and loads code can be changed using the import lib library, which is part of core Python, and it would allow you, for example, to maybe import code that wasn't written in Python as if it was. So there are lots of opportunities to write terrible Python code on purpose. So again, we may have got to this point, and I do feel like a third slide was maybe not necessary. So do let me try to actually explain why I do this sort of thing. So for me, it's this opportunity to try out a feature of the language that I don't necessarily have a use case for yet. And it's useful, it sometimes it builds a pattern in your brain, right? So one day you come across a problem, a real problem, and it kind of matches something you've done in the past for a stupid reason. But it's also a puzzle. Often, if you start out with your end goal and you kind of think, can I push Python that far? It's quite fun to kind of go through the intricacies of Python to try and get it to do what you want. I've also made friends online by showing stupid code like this. I have a small community of friends who I swap weird techniques with online, and so I kind of learn new techniques myself by seeing these sort of fun jokes in Python code. But mainly, I do it for the reaction that I get when I show somebody the code that I've written, or I post it on Twitter, and I get that response of somebody going, "But why?" So thank you very much, and I'm very sorry for wasting your time. Follow me on Twitter @GD2K, and come talk to me on the MongoDB booth. Maybe I'll tell you a tractor joke. Thanks very much.
Cool. Thank you very much, Mark. Anyone got any questions for Mark?
This should be fun. Why?
So more a question than a comment than a question. Right? It actually turns out that going through a list of functions and trying to write in a whole bunch of dunder methods dynamically in a class is actually quite difficult to do properly. And I had a reason to do that in production, but I can't remember why I did it.
You know that trick of, it is not quite related to what you said, but that trick of sticking an object in sys modules because there's certain things you can't do with modules that you can do with classes. Facebook have that in one of their core Python libraries that everybody in Facebook uses. So I hear.
Yeah, this is actually a question. So I saw that you have like using the R sub, the method.
Yep.
So what if the object on the left-hand side have a sub, and then they kind of contradict each other? So one is true, one is false.
So it's only going to call the first one. So if sub returns a value that isn't not implemented, then that is the correct answer. And what you would end up with is a weird situation where, in fact, no, that wouldn't even work. So, but yeah, it would never call R sub if sub is going to return a sensible value.
Hi. During your presentation, I was wondering how would I deal with your tricks, and I would write some tasks to check the type of your class, every classes, every method, and my question would be how you get along with this. But I realized you would fake the unit test, and
no, actually, I would do something much more evil than that. I would implement an abstract base class in a way that would just tell you that, yes, it was exactly what you were testing against. Yeah. So you can actually do that in a completely general way where I can test the type of that class against literally anything, like a string that says lemons, and it would go, yep, that's my type.
Thanks.
That's kind of fun to do. Maybe a topic for a future talk.
And anyone else?
Have you considered running a stupidest Python code competition every year?
I have now. What a great idea. Let's do this. I think that's probably it. The questions only get more silly. Thank you very much.
Okay, cool. Thank you.